now we're talking about a little more advanced things you can do with relays here. As I showed you here, this board with all the different relays on it, I pointed out that these are wired together here in series, all right? And what that means is that these are acting as a single switch. And this would be used in the case of if you are needing to have multiple things placed in one spot. All right. Let's say you're using RFIDs or reed switches and you need to have items placed in one spot and you don't necessarily want to wire these up to an Arduino and you don't want to wire them up to a controller and you don't have to. That's the nice thing. Or you don't have enough spots on your controller to wire all of them together. Well, what's nice is this wired together in this series configuration lets you be able to do a placement style puzzle because these all have to work together, right? And you can even make it where if something is here and something is here and something is here, let's say these three items, you place these down, but you actually don't need this one. So if this one's placed here, these two, the puzzle won't work. This one has to be removed, right? And there's a number of reasons and situations where that comes into play, sometimes with switches. Sometimes we built a puzzle where you have to sit in seats, right? But you can't brute force it by just having everybody sit in a seat. If somebody sits in the wrong seats, it prevents the circuit from completing here. And so that's what's going on here with this one too. You can see how I've got wires jumping out of this guy here. It's the same setup as this. This is just all in one convenient package. And this one also has the jumpers I was telling you about. You'll see here. This is another similar situation. These are all just ganged together that allow you to do this in a more convenient way. And so I want to go over that with you here kind of right now. All right, so let's say you have a puzzle where you need 4 different things to happen. You need 4 things, you either need 2 things or 4 things to happen. It depends on what you're going for, right? So here's your common here, and here is your, I'm just gonna put open and close here, all right? Because I don't feel like trying to draw an N upside down anymore. So here's your common here, and here's all your stuff. So the way this would work is you would, let's say you have the thing that you want to have happen, all right? So here's your LED right here like this, okay? And so here is your power source for the LED right there. And you've got your positive, you got your negative, all right? Your negative runs to here. Your negative always just runs to the negative of whatever it is you're working on, okay? So what's gonna happen is let's say you want to have everything activated to have this turn on at once, all right? So that means that you're going to have this going into your normally open, all right? So your positive here, let's do that. The positive of your item is going to run into the open like this. All right, then another wire is going to come out of the common, and the common is going to run to the open, and then the common is going to run to the open. The common is going to run to the open, and then the common runs out to the positive. So now when all of these relays have been activated, this will light up. And that basically all of this array acts as a single switch. Especially if you're using a controller, right? So if you plug this into your Fright Props controller, your Badass controller, whatever, your Arduino, whatever you're using, you only need, even though you have like 5 or 6, 10 things, you just need one set of wires to be running into your controller, right? So let's say this is, if this is your controller, what you would do is you would actually have, we'll just say that this is your control box. This runs out here and complete your circuit, right? You don't even have to mess with positive. You have positive, negative, ground, and everything like that. So this would just be telling the controller to do something else, to be like, hey, this has happened. Pop a maglock, right? Now, talking about maglocks, you could also have all these connected to another relay. All right. So imagine this is running to another relay, and then this relay is running to a maglock right here. So this is your maglock like that. So that would also be a way to do that, because your maglock would be connected to normally closed and common like that. So then when this flips, these are all correct, your maglock unlocks, right? So I know it seems a little complicated, but it's just the same thing over and over and over again. So let's say you want to do the same thing, but you want to have it where they can't be brute forced, right? The chair example I was telling you earlier, all right? So we're only going to use 3 relays this time. So let's use the same example we did before with the with our fourth and our maglock here. All right, so here is your maglock like that. So here's your power for your maglock like this. The negative, let's do this. Your negative here, negative runs to negative, positive runs to positive. This is common and normally closed. I'm just doing it upside down. All right, like this. And then here is your trigger voltage, and here's your signal. So that's kind of what's going on there. And of course, you can actually power everything off of one power supply. You don't actually have to have a separate power supply for each thing. You can power all these off of one 12-volt. You can actually power the maglock and this off of one thing too, but that gets into complicated-ish wiring that there's no reason to deal with right now. But in this situation, this could actually be powered off of the same source like this. So that's just something for you to know about. So here is our common and our open, our common, open, like this. So now this is going to be running into your signal, common to your open. Now let's say, actually I'm going to do here normally closed. So let's say this is the one that you don't want people to, you don't want people to touch or sit in, all right? So what's going to happen is you're going to run the common into normally closed like this, and then common over to open, and then common to signal like this. I know it seems like a lot, and it is. It gets to be a little confusing after a while, so you need to make sure you kind of organize your wiring and keep everything in kind of one situation. But so the reason for the normally closed is right now this switch is touching, right? So that's what's going on here. However, these that's what's going on there, and technically they're all doing that. So, but what's going to happen is if somebody touches this, sits in this, this is going to flip this way, which then breaks the circuit. Nothing happens here. This becomes useless in the circle of electricity. But when this one is activated, this one does what it's supposed to be. It flips over to here, and this one flips over to here. So these are getting power, these are getting power. But if somebody is, let's say these are chairs, somebody's sitting here, here, this flips. And the chairs, by the way, have sensors in them, like pressure sensors or buttons or proximity sensors, something like that. So now this flips over to normally open, which means this is now open. There's nothing connected here like that. So this would be flipped over if somebody sat on that. So now the electricity stops, as I mentioned. But if nobody's sitting in this, then that means these wires are touching like this. This becomes viable again, and it completes the circuit. So this electricity flows in one, and again, as we learned before, electricity is a circle. Here's what's going on, like that. It's just one circle here, another circle here, another circle here. It's 3 circles. And so when this happens, it triggers this relay to go from normally closed to normally open, which then makes your maglock separate, because when these are touching, the power is here, so there your maglock now has power, and then when it goes to normally open, pops the power, and this separates. I hope that makes sense. As I said before, one of the things people feel is a downside to relays is the fact that they click when they turn on and off. Now, there are things that are called solid-state relays, which means there's no moving parts, so there's no click. You can find DC to DC solid-state relays. They do exist. Most of the ones you're going to find, however, are these type right here. They have this black kind of housing on them and stuff like this. And these are a DC trigger, AC voltage. So you can't use DC voltage. You can't trigger DC voltage on this or turn it DC items on and off. It just won't work. You have to use these for AC items, but they don't make a noise when they activate. But you use these are a low level trigger, which means it's looking for ground to signal, right? And so you're going to use like a lower voltage. And so you always want to check your specs. Trigger voltage can be 5 volts, 12 volts, 24 volts. There's different types. And then what the voltage it can handle, as I said before. And let's see, they come in different flavors. Here's a timer relay. This is a solid state timer, so it's low level. It's a DC trigger. Timer happens. Trigger an AC thing here. these are all, I have so many different kinds of relays because almost any sensor you can think of has been attached to a relay module of some sorts. Here's an example here. This is a photo resistor that if you hit it with bright light or a laser, it'll trip this relay module here, and it works the exact same way. This one here is temperature. When it reaches a certain temperature that you've predetermined, clicks on this relay. There are ones that detect water, air, heat, all this stuff. There are so many different types of relays. And as I said, and I mentioned there's a timer relays. This is a timer relay. This is a timer relay, timer relay, timer relay. Now, as I said before, these aren't relays. These guys here are actually using a different technology, and they work differently than the relays. Relays have to be powered by two separate power sources. These can pass the power through it, which is great in some situations, but not others, right? So 12 volts goes in, that means 12 volts come out. So you can't power something of a different voltage with these, right? Same thing with this and a few others. So you want to be aware of that. This timer relay here, this one actually uses, instead of these digital readouts here, it actually uses little potentiometers, little pots, little knobs to set the time, which enables you to be able to, now they do make these kind with the digital readout with physical relays, the clicky relays on them. So do your research, because also every timer relay, this is also a timer relay, every timer relay functions a little bit differently, and there are a bunch of different kinds. So congratulations, you survived our 2 videos on relays here. I hope you learned something, and your education should not stop here. You should actually get a hold of some of these and experiment and see what the relays can do for you. If there's something that you felt wasn't very clear or you have more questions on, leave us some comments, get a hold of us over at testsubjects.com, and we'll be happy to help you out in understanding these and many other things. So we'll see you guys next time. Hey guys, make sure you check out some of these other videos we have here. And of course, if you want to keep up with anything we're doing, make sure you subscribe, click the bell, and make sure you also check out testsubjects.com for more info. And if you have something very specific you want us to go over, please let us know in the comments below. See you next time.